Good morning everyone. In this video, I am going to discuss a new property of the fluid, that is viscosity. So as we all know, we are discussing the properties of fluid and then we are basically solving problems associated with those properties so that it will be easy for you to revise for the exam. Now viscosity is nothing but the resistance that is offered by the fluid to the motion. So viscosity, generally it is denoted by mu. So let me write here. So please note the definition. Viscosity is nothing but the resistance to flow or resistance offered by the fluid. So it is a property of the fluid. So who is offering the resistance? Fluid is offering. So resistance offered by the fluid to the flow. Flow is nothing but the relative motion between the molecules of the fluid. So that is called flow. Flow is nothing but motion of the fluid. So when this motion is resisted or this motion is restricted, that property which is restricting the flow, that is called viscosity. Please note, viscosity comes into picture only when fluid is in motion. Fluid is in motion. So viscosity is there when the fluid is at rest also, but you can witness it only when the fluid is in motion. So this property is visible to us only when the fluid flows. So you can say witness only when fluid flows. So a very good example or very easy example you can think of is, for example, you take honey and you take water in a glass and then you just spill it and then you allow it to flow. So what you will see is that honey for a given time, let's say you have taken a glass, here in this glass you have honey and in this you have water. So let's say you are spilling it out or you are allowing it to flow. So you see, fix a time, let's say 10 seconds or 10 minutes. You see how much water is able to flow and how much honey is able to flow. Definitely, you will be observing that in a time span of 10 seconds or let's say 10 minutes, honey will not be able to cover as much distance as the water has covered. That means there is some restriction to the flow in honey. And what is it? This is nothing but viscosity of the honey is more than the viscosity of water. So like that, in simple ways you can understand viscosity is nothing but the resistance to flow. Now actually this flow happens in layers. Actually, when we study the flow, we study it in the form of at molecular level when we study. For example, let's say this is a fixed plate and you have a fluid on over this plate. So as soon as you allow it to flow, that means you are applying a force. This force is tangential. Basically, it is a shear force or a tangential force. So the stress or the resistance that will be occurring corresponding to this will also be tangential, or you can say it will be a shear or tangential stress. So this is the thing, that when you apply a certain force on this fluid, it will flow. Now when it flows, you will observe that the top layer will be moving, let's say to a certain velocity, capital V. Top layer of this molecule or this fluid will be able to move with a certain velocity V, whereas the bottom layer could come only up to this distance, or you can say it is moving at a velocity less than capital V. Like this, when you observe and when you see that at the bottom at the bottom of this fluid layer, that is the molecules which are just attached to this fixed plate, will be having zero velocity. So you see there is a velocity gradient that has set up. Now this velocity gradient has set up due to shear resistance or due to shear stresses that are generated. And why they are generated? They are generated because fluid has some viscosity. Please note that this shear stress has been generated. Why? Because of the viscosity of fluid. Now again, this shear stress is nothing but the force that is transmitted from one layer to another layer. That is, the top layer wants to move with a certain velocity, but the bottom layer is restricting it, and that is why the top layer is dragging it to some velocity, but bottom layer doesn't want to go with that velocity, so it will be moving with some velocity. Similarly, this process can be observed from top to bottom, but you see the bottom is fixed. This is a fixed plate. This is a fixed plate. So the molecules which are attached, at the bottom will be having zero velocity. The molecules which are attached to the bottom will be having zero velocity here. So you see a velocity gradient that has set up. Gradient means change in the velocity in this direction. If I denote this direction by y, if I draw the coordinate system, Cartesian coordinate system. So here this is my y direction. So you see there is a gradient that has set up in the velocity. U is nothing but I am denoting the velocity by U, or you can denote it by capital V also, like any which ways you can denote. So this is nothing but the velocity gradient. This is nothing but velocity gradient. How velocity is changing with respect to distance in the upward direction. So you see that this velocity gradient, it is observed that this velocity gradient is directly proportional to the shear stresses that are generated. Basically, you can prove that, what you can prove is this du by dy is equal to d theta by dt, where d theta by dt is nothing but the rate at which this angular deformation is taking place. So I can definitely say that the more is the force applied, the more will be the rate of deformation. Basically in fluids, we do not talk about the total deformation, we talk about the rate of deformation. So if I see that if I apply, let's say, some force and it is deformed by this angle, definitely, if I apply more force on the same fluid, it will be deforming to a higher rate. So deformation or the rate of deformation definitely increases with the force applied. So here I can say that the shear stresses, because this force is nothing but the shear stresses into the area of the contact of the fluid. This area, I'm talking about this area between the layers of the fluid. So this shear stress and area of the contact can be related to the force by this equation. Now, this shear stress is directly proportional to d theta by dt. How? Because more is the force applied, more will be the rate of deformation. So similarly, this can be proved by geometry, that how du by dy is equals to d theta by dt. If you look at, we have already proved in class. I'm not going to look at the derivation again. So I can simply say that it has been observed that the shear stress is directly proportional to rate of change of velocity, sorry, not rate of change of, it's directly proportional to the velocity gradient. So this is, if I remove the proportionality constant, this proportionality constant is nothing but viscosity. This mu is nothing but viscosity. This is also termed as Newton's law of viscosity. This, the fluids which obeys this relationship are called Newtonian fluids. Basically, this is Newton's law of viscosity. You can note down, this is Newton's law of viscosity, mu. So here, now again, we'll not go into much details. Viscosity denoted by mu in SI units, what is the unit of viscosity? It is Newton second per meter square, or you can say Pascal second. Pascal second. There is one more unit in CGS system, so that is called poise. Sometimes velocity is expressed in poise. Here you note that one poise is equal to zero point 0.1 Pascal second. Pascal second. So now quickly we'll move to the numericals based on this. Yeah, one more concept is there, that is called kinematic viscosity. So basically viscosities can be expressed in two ways, kinematic viscosity and dynamic viscosity. Kinematic viscosity is like, suppose there is a fluid. After you apply a force to that fluid, after it continues to be in motion, how fast it can move, that is nothing but kinematic viscosity. If you look at the dynamic viscosity, that means to move a certain liquid, how much force has to be applied. Whereas if you look at the kinematic viscosity, it is after applying a certain force, to what rate, at what rate it will move. So kinematic viscosity basically is denoted by nu. Please note, this is the symbol of kinematic viscosity. It is expressed as dynamic viscosity by density of the fluid. It is expressed as dynamic viscosity by density of the fluid. So here if you observe, in dynamic viscosity mass is included, whereas kinematic viscosity is independent of the mass. So if we look at the units of kinematic viscosity, the units become, it was Newton second per meter square, and this is in kilogram per meter cube. When you solve, the units will be meter square per second. The units will be meter square per second. These are the SI units of kinematic viscosity. If we talk about CGS system, it is Stokes, and one Stokes is equal to 10 to the power minus 4 meter square per second. So here I'll repeat what we have discussed in this property, that is viscosity, which is nothing but the resistance that is offered by the fluid to the motion. This property is only observed when the fluid is in motion. Only then you can observe this property. Then we discussed about the example of honey and water. So definitely honey has got more viscosity because it is more resistance to the flow. It shows more resistance to the flow. If you allow both honey and water to flow, honey will be covering less distance in the same time. So that shows that honey is more viscous. Then we moved on to Newton's law of viscosity, wherein he has observed that shear stress is directly proportional to, it has been observed, again it has been observed for some fluids, not all the fluids follow this observation. So those fluids which follow this observation, they are called Newtonian fluids. So in this observation he found that shear stresses are directly proportional to velocity gradient, and velocity gradient is nothing but, you can observe the fluid molecule which is just next to the solid boundary or to the fixed plate will be having zero velocity. Why zero? Because it will take the velocity of the fluid plate, of the plate which is present here. So plate is fixed, that means the plate velocity is zero. That is why the molecule which is next to this is also having zero velocity. Basically this is called no slip condition. No slip condition. At the boundary, because the boundary is fixed, the molecules which are attached to the boundary will also be having zero velocity. But when you move on the top, this effect reduces, and the maximum effect of this force, of this shearing force, will be observed at the top. Layer by layer layer by layer due to transfer of forces, this resistance comes. Now, again, when you remove this proportionality constant, there will be one constant that is called proportionality sign. When you remove this is mu, this is nothing but a constant of proportionality which is called viscosity. This is viscosity. So, this is viscosity represented by mu. The units of viscosity are Pascal second. You can derive here. This is stress, so it can be Newton per meter square, and this is velocity change, so definitely meters per second, and this is in meters. So when you solve, you will get the units as Newton second per meter square. Newton per meter square is also termed as Pascal, so you can write here as Pascal second. Again, there is one more system that is called CGS system. In this system, units of viscosity is poise. One poise is equal to 0.1 Pascal second. Similarly, there is one more viscosity that comes into picture, that is kinematic viscosity. It is independent of mass. So two liquids can have same viscosity, but their kinematic viscosity will be different because their densities will be different. Okay, so here in the SI unit, the kinematic viscosity SI unit is meter square per second, whereas in CGS system it is Stokes, and one Stoke is equals to this. Now please note viscosity varies with temperature. It is a function of temperature that we look at how it will vary in the coming lectures. Now here I'll give you one very simple problem, because again our agenda is to discuss problems based on these properties. So quickly I'll give you the the problem. So here the problem is, there is a plate which is at a distance of which is at a distance of 0.025 millimeter away from a fixed plate. So there are two plates basically, one is fixed and one is moving. The one which is moving is at a distance of this much distant. Now this plate which is moving, it moves at 60 centimeters per second. This much is the velocity of the plate, and it requires a force of 2 Newton per meter square. So basically this force is expressed in terms of intensity. So you can see per meter square of plate needs this much force to move. So I hope you understand. What we have to find is find out find out. So this much force is required to move, or to maintain this much speed, this much force is required. Find out the viscosity, whose viscosity of the fluid which is in between the plates. So you have to find out basically the viscosity between these viscosity of the fluid which is present between these plates. So there are two plates, one is fixed and the other one is moving at a velocity of, sorry, this is u, should not confuse, u is equals to 60 centimeters per second. So this is the velocity with which this plate is moving, and to make this plate move at this much velocity, the force that you need is 2 Newton per meter square. There is a fluid which is offering resistance to this plate, because fluid has some viscosity and the plate is moving, so fluid will be offering some resistance to this movement because fluid is not inviscous, fluid is having some viscosity. If the fluid is ideal, that we'll discuss again. If the fluid is ideal, that means if the fluid does not have any viscosity, fluid will not offer any resistance. So again, simply you can use the Newton's law of viscosity, that is nothing but tau is equals to mu du by dy. So there are shear stresses generated on this plate due to viscosity, and those shear stresses are denoted by tau, and tau is equals to mu du by dy. Applying the Newton's law of viscosity on this fluid, tau is nothing but shear stress, that is nothing but force per unit area that will be there. So here already it is given to us, as 2. Now mu is something which we have to find. Now du is what? Du is nothing but the change in the velocity, which change from here to here. Please observe that here the velocity is 0 and here it is 60 centimeter per second. So what will be the difference? Difference will be 0.6 minus 0. Du is nothing but change in the velocity over a distance y. So here you see that here I have put it in the meter per second. I have kept it in the SI unit, so it will be 0.6. And dy is what? Dy is nothing but the distance over which this velocity has changed. The distance over which the change in velocity has been observed. So it is nothing but 0.025. 0.025 mm, which is given in the question. So quickly I will write down it as 0.025. So 0.025 into 10 to the power minus 3. So please understand, like I am repeating it, it is 0.025 into 10 to the power minus 3 and this is 0.6 minus 0. So from here you can solve and get mu as, 8.33 into 10 to the power minus 5 Newton second per meter cube. This is the value that you will get after solving this. So it's nothing but you take this here and cross multiply, you will get the value of mu. So this is a question based on a viscosity. Now similar type of question I will be giving you and then you can try it out. So the question that is given to you as there are two horizontal plates. Basically there are two horizontal plates and the top plate is moving with a velocity of 2.5 meter per second. Top plate is moving with a velocity of 2.5 meter per second. There is a liquid between these two plates and the viscosity of this liquid is given to you as 14 poise. So one of the plate is fixed, the other plate is moving with this much velocity. Viscosity of the fluid is also given, and the distance between these two plates is 1.25 centimeters. 1.25 centimeters. So you have to calculate the shear stresses. Calculate the shear stresses generated in the fluid. So definitely shear stress will be generated. Why? Because viscosity is there, because there is some motion. Due to this motion, viscosity will come into picture by resisting the motion, and when this fluid is resisting, there will be some shear stresses generated in the fluid. So basically you have to find out, and this is it about this viscosity at this level. And then you can solve this question, post your answer in the comment section. Thank you so much for watching it. Soon we'll be covering most of the properties of the fluid and basically the numericals associated with the properties of the fluid. Thank you.